All right, welcome everybody to episode 2 of season 2 of Tech Talk Tuesday. Joining us today is Idral Bowen. He is the regional sales manager in the Southeast. Many of you joining us today probably know Idral, and if you don't, he is a longtime baseline guy and a world of knowledge. If you're in the Southeast and have questions, Idral's your guy. We've got Dan Conger. He's our training manager. Chris Wright, our VP of sales, and I'm Andy Humphrey. And let's see, definitely some new names I'm seeing here. So if this is your first time joining us and you want to catch any of the replays, Dan uploads them typically same day. You can find them on the Baseline YouTube channel, which is Baseline Web Training. It's all one word on YouTube, Baseline Web Training. All of the past Tech Talk Tuesdays are there, as well as lots of helpful videos. I know I used some this week in regards to how to register a cell modem, how to create a base manager account, how to add new users. All of those types of videos are available on the YouTube channel to help you guys out. Yep. And today we're going to be sharing a case study that's one of Idral's projects on Auburn University and some of the technology that we have implemented there. So I think with that, Dan, let's have you kick us off.
Awesome. Cool. Well, so we're trying something a little different this season. So this week, we're going to talk about Auburn University and this case study and how they kind of solved some problems, how they did solve some problems in there. And then next week, I'm going to drill down and get into some of the real programming and some of the set points and things like that. So if this is interesting to you, come on back next week for more of the same. So I don't know Auburn University. So, I mean, I know it through Idral. So I did my Wikipedia research, and we're going to see how many of these Idral is going to correct me on. So a little bit.
I know they did not win the national championship last night.
Was that in basketball?
Oh, oh wow!
Break one.
California is under a rock.
Yeah, I just exposed my sports inaptitude. Okay, Auburn is in Auburn, Alabama, right? I got that right. Good. Okay. Good. University opened in 1859, so it goes back a few years. They've got over 25,000 students on campus. That's not counting upper graduate students. The site covers 1,800 acres. And I want to share my screen because I've got a picture of the site. So let me bring that up and share it. There we go. Okay. So 1,800 acres, which is pretty enormous, right? That's like, to me, we're seeing a small city here. But today we're going to talk about the project portion that is the Recreation and Wellness Center. So Idral, would you tell us a little bit about the Recreation and Wellness Center and how long it's been around there?
Okay, well, this is the new recreation complex that we're actually talking about. The Wellness Center is another site within the site on campus. And so at the top here, you'll see the intramural fields, which have been a part of the university for several years. And then the bottom, you see the construction area. They've added artificial turf, softball fields, football fields, and soccer fields. And so now they expect to be able to handle a lot more traffic on all the intramural activities. So a big step forward for Auburn. They were pretty well locked into just that one field before.
Right. So the intramural field is real turf, and then those two baseball diamonds or softball diamonds, and then was it maybe a soccer field or something like that?
2 soccer and one actual football is
okay. But where I'm going with that is we can see some synthetic turf and then some real live turf. That's going to be important in our story as we come around, right? Okay. So their plant material was it sounds like we had grass, turf, shrubs, that traditional irrigation and traditional plant material, but then that artificial turf, right? They wanted to keep that wet, right? So what were they using to water that down and keep that going?
So they're using the large Hunter in-ground turf rotors. They use about 250 gallons a minute, and they're used basically to either cool down the turf, or they're used to rinse it down high volume amounts of water. They have a 12-inch main line that's looped around the artificial fields. So they expect high water usage.
Yeah, right. Okay, so some large consumption through that one. Okay, awesome. So I've got a bit of a diagram that's kind of showing some of their water supplies, right? So they've got 4 wells scattered along the property or along this portion of the property. That's fantastic. Wells are great source, but these wells don't produce a whole lot of water. Do you remember what the flow rates were on these?
Yeah, the total is about 80 or 85 gallons. So one's 10 gallons, one's 25. Not real high production as far as recharging.
Okay, so wells that flow really low. They've got a city water for some makeup, and that's pretty high. If I remember, that was in the 300 or 400 GPM.
Correct. We can get 350, 400 gallons a minute out of the city water fill.
So even though water in Alabama's got to be cheaper than my water here in California, I got to imagine that the wells are the preferred water supply.
Absolutely.
Yeah. Okay. So then this all feeds this 64,000 gallon cistern in that upper corner there. So all those are dumping in to keep this cistern filled. And then that cistern is supplying that pump station. And the pump station, pretty high flow on that one, 1,200, 1,500 GPM, if I remember.
Right. It's got the capacity for up to 1,500 gallons. It's got to be able to handle several of those big guns. But at the same time, it also handles the smaller turf and scrub and even some drip zones. So it's...
So when we bring in those main lines, so here's those main lines we're talking about. So we've got multiple main lines that are out here, but it's those big rotors that the crux. I think some of the crux of what's going on here is where we're coming to the hard point of this. So 64,000 gallon cistern. I did a little bit of math on this. If we have a pump station that's capable of 1,500 GPM, and we have 64,000 gallons capacity, that's 42 minutes of runtime before it's empty. I mean, and that would be empty. Okay. And then we got 80 GPM of well water and 300 GPM of city water, even if we used them all at the same time, that's 2.5 hours of recovery time. I think that's the crux of here. And so there's some serious juggling of water supply and storage issues here, right? So that kind of brings us to what I think is the first question is, why did they pick Baseline on this project? Well, isn't it to solve that flow management and that water source management issue? That was the main purpose of what this was, to solve that problem.
Yeah, and I think we're from some of the projects I've worked on that are very similar. You could those wells and those other cities and those hydrometers could be managed by another control package, right? Could be some other kind of a pump station, some kind of another control system, PLC, and you're going to spend $10,000, $20,000, $30,000, some odd amount of money to manage all of those sources that fill that cistern. However, we can do it right, all baked into the 3,200, right? With just a little bit of extra cost, it's all there. So there's me speaking for Idral on why they chose Baseline.
Yeah, I'm sorry I missed my cue there, but the whole idea was it had to be automatic and automated. Yeah. So we're using some sensors that are placed in the cistern. It's a Watertronics pump station, and they're providing a signal to our event bicoders. And so we're actually at a certain level of inches inside the cistern, we're turning on the wells to start recharging. The wells can almost keep up with the smaller turf stuff. It can run for several hours. If we turn on the big guns, which is not a regularly scheduled schedule, it's not like turf. You don't have to water it to grow. So there's kind of extreme situations. So the system is set to start and it stops automatically based on those sensors that are in that tank. We also have a drop dead event bicoder, which means if in fact the cistern gets to a certain number of inches, we stop all irrigation on our part to make sure that we don't send the pump station into a a shutdown, which requires a human to go restart it.
No.
So we're a fail-safe part of the system to make sure, a human doesn't have to go restart the pump station.
Yeah. I think this highlights beautifully the concept of how Baseline manages water sources and then control points, right? Because traditionally you would think of a point of connection being the pump station. That is what is feeding the irrigation system its water. But in reality, we're dealing with multiple water sources that are controlled by multiple control points that are monitoring and managing that flow of water to give the performance that is required and expected based on the design intent of the system itself.
Mm-hmm. Yeah. And I think Dan, tomorrow you're going to get into the details of how this is set up, but it's also just good to know that there's no one way to set this up. So there's a couple different ways that you could configure this programmatically based on what the needs of this site are. So you could set them up as water sources. Remember we have the start, stop, pause. So you could set up programs to fill based on start conditions. And so there really isn't one way to skin this cat. There's a couple different ways that you can program it to, based on the needs of the site.
The other thing, back to Idral's point on having a human, have to go out and reset that is, I think, automating it and making it much more foolproof, because when you have manual valves that you need to open and close, it would be really easy to deadhead against a closed valve, right? To have a pump closed, pumping against a closed valve and damage devices. Or you could be pumping water back into the city when you shouldn't because the wrong valve was open. So by automating that, we can prevent a lot of those problems. So cool. Okay, so let's take a look at the hardware that they used to do this. And this was really all the hardware that they needed for it. So they needed a base station 3200. And reminder on base station 3200 is it can handle up to 200 zones, 8 water sources, 8 control points, and 8 main lines. So how many zones did they have on this site, Idral, in their configuration?
Yeah, we ended up with 122.
Okay, so well under the capacity of the base station 3200. So they actually have some room for expansion on this one. So why did they need, we've got the substation. And so the substation is an extension of the base station 3200. So they could put zones on there. And why did they need the base station, the substation, excuse me?
Well, they sort of ran a little extra wire and outstripped the specifications electrically of what one controller could do. So we split it in half and basically cut the load in half, the electrical load, for both controllers to make sure we keep everybody happy.
So there's,
just as a reminder too, that substation is communicating to the 3200 wirelessly, right? So you placed it at some known other point on site, and now you're linking to it wirelessly, not with a wire, so that your new 2-wire path, when you split it, originated from the substation instead of originating from the 3200 controller.
Yeah.
Right. We dead-ended one of the wires that went into the 3200. And actually what we did is we had a 5200X, which is a different product we're not talking about, but they were adding those intramural fields in through that device. And we just added a couple of boards. We did put hardware, but we added a 3200. And that's how we found our new place for the second controller, was an existing station location, and then put a cell modem in it. And now they connect via cell modem and through their Ethernet system at the university through our cloud, the IoT system.
Good. So you just answered one of my next questions, was the communication. So the one of them is using, one of these devices is using I believe it's the base station 3200 is using a cell modem to communicate to base manager, and then substation is sharing its data with the base station 3200 via an Ethernet connection.
Correct.
So right now we have two different methods of communication, and traditionally our substation has had a direct communication method back to the base station 3200. But now that we've got these two different forms of communication, Ethernet and cell modem, that's not the same network. And that's brought together with our cloud networking or IoT option, and allows you to use different methods of communication on multiple different devices, but still share the data across our server. So I think that's not an option that we had in years past. So I think that's a
and
cool.
just maybe I should repeat that one time in case somebody was checking their email while Dan said that. The substation, as shown in this picture, is not communicating wirelessly directly to the controller. Both devices talk to our server, and the server sits in the middle. The server is like the middle manager. So the controller talks to the server, substation talks to the server, and that's how they communicate together, is through our IoT server.
Cool. Okay, so between these two devices, we've got 122 zones out there. So then the next device they used some flow meters or flow sensors, right, to measure flow at various points, because we need to know how water is moving through the system. And they had 8 flow meters, and then 8 master valves. And then some of those, they combine those flow meters and master valves together into hydrometers. But that's either way you look at it, we've got an option of 8 flow devices and 8 master valves. They currently don't have any pressure sensing on the system, but they have an option for another 8 pressure sensing. So these combine those together, and that's what we call a control point. And then they used 4 of these event switches or event bicoders. So let's fill me in on how those came into play and what they used those for.
Okay, so there's a sensor in the cistern that is set up through Watertronics. They utilize the signal for different things that the pump needs to do, but we also utilize the inch. It's measuring in inches the amount of water in the cistern, and so based on the level, and I guess we should have mentioned earlier, we can't actually use the full 64,000 gallons. We can only use everything above 35 inches. Below that is below the suction line. So it's even less water than you think, but it is capacity of 64,000. So as those inches, as the water changes in the level, the different event bicoder gets a signal that tells either the wells to kick on or to kick off. And one of them tells the schedules the entire system, except for the wells. They all have a kill switch, if you will, a master kill. They can't go below a certain number of inches. That still leaves us a certain amount of safety level in the tank, so we don't get a low pressure shutdown on the pump station. And then we also have a kill switch, if you will, on a event switch for the city water to stop well before it gets to the top, because we don't want to overflow. So there's a safety to keep it from going too low and a safety from going too high. So that's how we're using the 4 event bicoders.
And are those attached to a mechanical float?
No, it's all electronic. It's a 4 to 20 milliamp device that we're getting a signal from. So if this project would happen this year, we'd be using our pressure transducer instead of their sensor, but that's another story.
Right. And what makes this all possible, guys?
Baseline
2-wire technology.
Right on.
And we're going to say this a lot every time, probably, right? The differentiator when we say baseline 2-wire technology is the 2-way data communication. We're able to grab information from the devices in field and send it to the controller, and we're able to send commands from the controller to the field. And so when we talk about 2-wire, we're talking about a data communication cable. It's not just turning valves on and off. And we're going to just keep repeating this every time we're with you guys. Right. So just one more opportunity.
To compound that thought, Andy, it's real time, right?
Real time.
What we're talking about and dealing with this cistern and those levels, you need to respond in real time, right? And if they aren't mechanical switches levels that are in there that will trigger a relay switch per se, then that real-time data is even more important. So it responds when it's supposed to that condition.
Absolutely. Just thinking about, Idral, what you said about that 36-inch level line. And if you're pumping out at 1,500 gallons a minute, you could drop below that in a matter of 3 minutes. You could be well below that 36-inch line if we weren't responding quick enough.
Right.
Nice. So coming back to the event switch or the event bicoder, it's really just a way to interact with another device, right? To take input from somebody else's sensor or one of our sensors or one of a device, and then program it and do things with it. So that's how we were able to interact with someone else's pressure or level indicator, not ours. But we have lots of different ways, and we've talked about that in the past, and we'll have some more this year we're talking about.
And you have to prearrange that too. That was done with through the specification process with the designer to make sure that we could interact with the pump station, because we knew we had to have that input. Nice. So you've got to kind of plan ahead.
And Idral, are we allowed to share who the designer was or speak to that at all?
Yeah, sure. It's Bob Scott out of Atlanta, Georgia. ICS is the name of his company.
Nice.
Great. Yeah, Bob Scott's an excellent irrigation designer.
So I've thrown out some terms, and I wanted to loop back to them, because this is another core fundamental of our systems. Is there's three components we talked about. The water source. In this case, the water source is the pump station. We aren't using it as the wells. We're not using it as the city water. It's not the cistern. It's actually the pump station. So we're going to set the limits on that. Now we can handle 8 different water sources. So I could handle 8 pump stations, or a pump station and a water meter, if those were directly feeding the main line. But since they're feeding the cistern, the pump station is our water source. The control points, which we can handle 8 control points, can be a master valve, a flow device, and a pressure component, right? Or it could be just one of those, or all three of those. They're only using the master valve and the flow component. So they have another 8 pressure devices they could fit on the system. And then the main line, right, carries the pressurized water out to the zones. We can have 8 different main lines. So keeping those terms in mind brings us to the programming solution that they did on this one. So here's kind of how they set up the programming. Is the wells in that city water supply, they feed the cistern, that 64,000 gallon cistern, whenever the level drops below a certain level. So it starts dropping it from those event bicoders. It tells it, I need to start filling. So the event switch uses a start and a stop to run those wells and the city water if needed. And that cistern feeds that 1,500 gallon pump station. The pump station is the water source. If there's an empty condition, or if it drops too low in that cistern, it will stop, right? And it's just full on stop, discontinue this water source. In this case, since they only have one water source, done. If they had another water source, it could then go to the backup or the alternate water sources. And then this cistern, or this pump station, if you will, feeds all the main lines. Okay, so then let's bring in the main lines on the programming solution.
So before we move past the cistern, let's just clarify, because the question came in, what are they using to monitor the levels exactly? So the question was, are they using the soil moisture sensors to measure the level, which is not the case. They're using some other type of sensor interfacing with our event decoder to monitor and measure that level. So what's the device, Idral?
It's I guess technically it'd be called a level transducer. It's a device that you string into a cistern, and it sits on the bottom, and it measures basically the water pressure on top of the device to give you a measurement in inches. So
Idral, are they using our event bicoder, or are they using our pressure decoder?
No, good question. I knew that was coming. So it's coming into their system, and it's going into one of their devices, and it's providing us a signal after the fact, either an open or a closed situation. Okay. We can do the same thing now with our pressure transducer bicoder, and hopefully in future designs we'll be doing that. But in this instance, we're taking just a simple open or closed signal from the pump station to do what we need to do.
The next client will save some money with us.
Actually, I think this is an awesome. I'm going to definitely bring this up next week, because I think this is really, really intriguing. Right? We're not actually taking pressure data. We're just taking the pressure data is running to their system, and their system is turning off or on a switch. That's all it's doing.
Yeah.
If you would, it's an indicator light. And we're just saying the switch is open, switch is closed. That's it.
Right.
So the actual tool, though, is the pressure device, but it's going through someone else's system.
And, when we use our pressure transducer, we can see the actual inches in the tank and measure it that way, which is, to me, it's a little better for my users, because they can see through our system what the level is of their cistern. So anyway, that's to simplify it, but
yeah, but at the time of this project, we couldn't do it. So that's why we used what you had.
That is true. That's right.
Yep. Which illustrates that we're always innovating.
Yeah. Right.
Right. And always finding unique use cases and finding out how to adapt our technology to it.
Cool. Okay. I got one more. So that's the supply side. And let's look at the mainline side. So on the mainline side, those big rotors, those are assigned to a mainline. And I don't know if it's mainline 1, but we're going to call it mainline 1. Because remember, we have 8 different mainlines we can use. That mainline is a 12-inch mainline. So it's got a really high flow limit, right? It can carry a lot of water. So they've set those limits quite high on that. So those big guns are on that mainline 1. But those landscape zones on that 4-inch mainline, that's a different mainline. So probably mainline 2, and it has a lower limit. So what's awesome about this is if the 4-inch mainline breaks, we're going to say this was the limit. If it was, I'm going to grab a number, 300 GPM, that's the upper limit. Maybe that's a little too high, but the 12-inch needs to be even higher. That might be, 800 to 1,000 GPM before it hits its upper limit. So we can have different limits for different main lines because that's part of the controller. So I think something I thought was kind of interesting, we brought this up the other day, Andy, was that this is all based in with the base station 3200, right? There's nothing additional. The event bicoders was really the only thing that was a little bit different. Everything else was baked into the firmware of the base station 3200.
Yeah. And I think it'll be exciting next week. Hopefully you guys will join us again, because Dan's going to go deeper into the programming. But my kind of takeaway on that tank fill, as I was looking at it on the screen, was that it's, sort of a on-demand tank fill that's fully automatic, that is not requiring a start time, a run time, or a day of the week, because we're using our start and stop conditions, that tank can fill and come on and off and on and off, regardless of the demand on the irrigation system. So we've got your mainline 1 and your mainline 2 that are operating on, start times, run times, days of the week, and that's off doing its thing. And then behind it is this automatic tank fill that's occurring. And those two things are happening all at the very same time concurrently.
Yep.
And we also have all the tank filling schedules. They're not adhering to any of the rain shutoffs or things like that. They're totally separate from the regular irrigation. It's designed to be completely automatic, autonomous all the time.
Excellent.
Very cool.
Yep. So join us next week if you want to figure out how Idral programmed all that.
Yeah. And I think we've got some finished pictures also that we can share next week of the project once construction was complete. So definitely worth carrying on this conversation, because we talked a lot about baseline capabilities and didn't even really get into depths of how it all works.
Right.
Yeah. So a part 2 is warranted for sure.
Absolutely.
So, nice work, Dan. All right. Very good. We don't have any other questions that have come in. So we are at our termination time. We thank you for joining us as usual. We appreciate your continued interest in the information that we have to share on a weekly basis. And most of all, we appreciate you using baseline technology to manage your water on various types of sites, and that you see a benefit from that. So we'll keep building it if you keep designing with it and using it. And we look forward to coming back around on this project again next week.
Cool.
So everybody go out, have a safe week, work hard, and we will we'll tune back in next Tuesday.
Awesome. Appreciate you guys. Thanks for joining us.
Cheers.
Take care.
Bye now.
Bye-bye.